Dear students, today I am going to discuss another problem in realization of IIR filter. Obtain direct form 1, direct form 2, cascade parallel for y of n equal to 0.75 y of n minus 1 minus 0.125 y of n minus 2 plus 6x of n plus 7x of n minus 1 plus x of n minus 2. So the obtained equation will be taken, and here directly I am not going to take is a transform. So what I'm going to do, whatever the x values is there, that I'm going to taken as the w of z. So w of n is nothing but your output, x of n is nothing but your input. Now y of n is nothing but your output, overall output. Now direct from 1. So here x of n. So x of n is nothing but your input, w of n is your output. So first what you have to do, x of n, multiply the coefficient is 6. Next, delay the input by 1 time, multiply the coefficient 7. Delay the input by 2 times, multiply the coefficient 1. See, x of n, no, it is not delayed, so directly I am added and it is multiplied with the coefficient 6. Next, input, delay the input by 1 time and multiply the coefficient minus 1 and then added. Next, delay the input by 2 times, so directly I tapped here, multiply the coefficient 1 and then added. The next one is your output. What is your output? Output y of n equal to 0.75 y of n minus 1 minus 0.125 y of n minus 2 plus w of n. This w of n is nothing but your input. All will be added. So that here it is mentioned w of n. So what you have to do? Delay the output by 1 time, delay the output by 2 times and multiply the coefficient 0.125, multiply the coefficient 0.75. See, delay the output 0 z power minus 1, multiply the coefficient 0.75 and then add it. Next, delay the output by 2 times and multiply the coefficient minus 0.125 and then add it. So this is direct form 1. And direct form 2 realization means the same thing you are going to take this side, and this we are going to replace this side in order to make the common delay. See, in order to make common delay, this output will be taken and this input will be taken this side and making the common delay element in order to reduce the delay and in order to save the memory. The next one is cascade. Cascade means nothing but same, you have to implement direct from 1 and 2 only. Cascade means multiplication of the two transfer function. Okay, so now I'm going to simplify the given equation. What is the given equation? Y of n minus 0.75 y of n minus 1 plus 0.125 y of n minus 2 is equal to 6 into x of n plus 7 into x of n minus 1 x of n minus 2 is transform. Now I'm going to make y of z divided by x of z. Y of z divided by x of z equal to 6 plus 7 z inverse plus z power minus 2 divided by 1 minus 0. So this I can write it as y of z divided by w of z into w of z divided by x of z, like last problem. So after simplifying this one, now this denominator I will simplify z power 0.5, z power minus 0.25. So this is my one transfer function, this is my another transfer function. Now for this h1 of z, I have to take the z transform 1 and direct form 1 and direct form 2. And for this h of 2, I am going to take direct form 1 and direct form 2. See, for the first transfer function, I have taken direct form 1, and the second transfer function as I've taken direct form 2. So now cascading these two things, this is your cascading of this 2. Okay, now cascading this x of n will be, this is your just joining this two h1 of z and h2 of z. Next one is parallel realization. Parallel realization means it is adding the first transfer function to the second transfer function. So that what we have to do, the denominator equation we have to split using partial fraction method. Now my h of z will be equal to, this will be h1 of z plus this will be h2 of z. Separately I have to take h1 of z, separately I have to take direct form 1 and direct form 2, and separately I have to take the direct form 1 and 2 for both. This h1 of z also I have to take direct form 1 and direct form 2. The h2 of z also I have to take direct form 1 and direct form 2. After that I am going to add both this the h1 of z, this is h1 of z and this is h2 of z. This is the common input and this is the common output. See here, this here the denominator equation, whatever it is given in, if they are given in cascade realization, directly we can multiply this 6 plus 7 z power minus 1 z power minus 2 divided by 1 minus 0.5 z power minus 1 as h1 of z, and for h2 of z 1 divided by 1 minus 0.25 z power minus 1 you can take, or else you can take 1 divided by 1 minus 0.5 z power minus 1 as h1 of z. 6 plus 7 is z inverse plus z power minus 2 divided by 1 minus 0.25 z inverse will be taken as h2 of z. Okay, but in parallel realization, parallel means nothing but adding one transfer function with other transfer function, so that only we are going to use a partial fraction method. Using partial fraction method only we are going to split the equation like this. First a value, b value you have to find, and then this is h1 of z and this is h2 of z. Both you have to add it with the common input and common output. This is about your parallel realization. Okay, thank you students.